Hello everyone, welcome to my channel and welcome to yet another video on integration. In this video I have only one integral that I would like us to look at, and it's the integral of cos 2025x times cos 2020x dx. So we need to evaluate or integrate this expression here. How do we approach it? Well, here is how we approach it. Obviously when you look at 2025 and 2020 x, there is no way you can expand that by using whatever technique. There has to be a trick that we need to perform, and the trick is as follows. So this is page 1, and we have the integral of cos 2025x times cos 2020x dx. And the trick is, when you look at cos there, it should remind you of the following. Cos of alpha minus beta is equal to cos of alpha cos of beta plus sine of alpha sine of beta. Now let's get the one with the plus sign. Cos of alpha plus beta is equal to cos of alpha cos of beta minus sine alpha sine beta. That's compound angle formula. So now when you look at cos there, it means we need these two terms here, and the way that we get these two terms is by simply adding the equations so that these can fall off. So we add the two equations. You'll agree with me that these two cancel, and on the left you just have cos of alpha minus beta plus cos of alpha plus beta. This will be equal to, these two will just give you 2 cos of alpha cos of beta. Now if you look at this part here, we have cos, we don't have a 2 outside, so we have to divide by 2 both sides. So dividing by 2 both sides, we have this expression here, cos of alpha minus beta plus cos of alpha plus beta, and we're saying half of that, it should be equal to cos of alpha cos of beta. Fantastic. Now we can put 2025 here, 2025x and 2020x. In that place, we must do the same on the left. So we're basically saying this implies half of cos of 2025x minus 2020x, like so, plus cos of 2025x plus 2020x. That part should be equal to this part. Now we have to say cos of 2025x cos of 2020x. Now let's simplify the left hand side. Simplifying the left hand side, we have half of cos, that is 5x, as you can see, 5x plus cos, that is 45x, 45x. This is equal to cos 2025x cos 2020x. Fantastic. Now you can see that this expression here can be replaced by this term on the left hand side, half of that, and therefore the integral changes to, I'm going to put an arrow here, let me squeeze it in here. The integral, this integral here changes or is transformed as follows. We have the integral of half of cos 5x plus cos of 45x, and what do we say, dx outside. Look at how nice this integral is now. So continuing from here, all I have to do is distribute the integral the half and the dx as follows, taking us to page 2. Taking us to page 2, now what we have is that integral is equal to, it's the integral, like I said, half cos of 5x dx plus, remember that half has to be distributed as well, plus half the integral of cos of 45x dx. Right, at this stage, I've been requested not to just go straight to the solution from here, otherwise we can, but I want to say at this point, let 5x be equal to some constant, let's say u, and therefore from here you can see that 5 dx will be equal to du. But if you look at this part here, we have dx, divide by 5 both sides, so we have dx is equal to 1 over 5 du. Now let's come to the other part. This part here, you're gonna say let 45 x be equal to v, for example, and therefore differentiating both sides, you have 45 dx, the answer will be equal to dv. Divide both sides by 45, dx will be equal to 1 over 45 dv. Right, let's perform the double substitution. So this integral therefore is transformed as follows: half of the integral of cos of u, remember the 5x must be replaced by u, and then times dx is replaced by 1 over 5 du. We have to say plus half there, the integral of cos of, instead of 45x, we're going to say v, and then we say times 1 over 45 dv. Now we take this out and that out. What do we have? We have 1 over 10. Remember, half times 1 over 5 is 1 over 10, times the integral of cos of u du, plus multiply 1 over 45 times multiply 1 over 45 and 1 over 2. The answer is going to be 1 over 90 times the integral of cos of v dv. Now you'll agree with me that the integral of cosine is just sine. So here we're going to say 1 over 10 sine of u plus 1 over 90 sine of v, and then we say plus c, because this integral is an indefinite one. But what is u and what is v? You can go back there, take those expressions, put them back in. So our final solution then is going to be 1 over 10, and then we're saying sine of 5x. Remember, u is 5x, plus 1 over 90 sine of 45x, and then we have to say plus c and as our final step. So this is the final solution to our integral. Now you tell me if this is not brilliant, because otherwise it would be almost impossible for you to evaluate that integral without the use of compound angle formula. So this is just one example where you apply compound angle formula and you're able to evaluate or integrate expressions that look almost integrable. All right, if you're new to the channel, support us by subscribing. I'll see you in the next one.